Hi, in this video we will discuss case study 2. This case study 2 is covering chapter 3 about angle of twist. This is the typical question for angle of twist problem. The torque shown are exerted on pulley A and B. For pulley A, there is 300 Nm, and for pulley B, there is 400 Nm. Knowing that the shafts are solid and made of steel, with G equal to 77.2 GPa, we need to determine the angle of twist between rod A and B and the angle of twist between rod A and C. To solve this kind of problem, we need to list all of the known given in the question. We have G equal to 77.2 GPa, and we have the dimension of the system. We have TA equal to 300 Nm and TB 400 Nm. First, we need to draw the free body diagram of the system. To find the TR of the system, we can use a sigma moment equal to 0. And then we have a TA plus TB minus TR equal to 0. And TR will give us a 700 Nm. In the first question, we need to find the VAB, or the angle of twist between rod A and B. We can use this formula to find the VAB. TAB times LAB over GAB times G. So, we need to find the internal torque exerted between rod A and B. We can use a sigma moment equal to 0, and we will have TAB equal to TA, which is 300 Nm. For the LAB, we can obtain from the dimension of the system, which is 0.9 meter. For JAB, we can use a P over 2 times C to the 4, and we can obtain 7.95 times 10 to minus 8 meter to the 4. By substituting the value into the equation, we will obtain 0.44 radian, or approximately equal to 25.21 degree. To answer the second question, we can solve by using a partition method. This is the first partition that we create. We need to find the VAB. And then this is the second partition that we create. We need to find the VBC of the system. By combining VAB and VBC, we will obtain the VAC, because VAB of the system will be twisting relatively to VBC. So, by combining VAB and VBC, we will obtain the VAC. Because we have already done for the first partition, we will go directly to the second partition. This is the second partition of the system. We need to find the TBC, or internal torque exerted in rod BC. We can find by using a sigma moment equal to 0, and it will give TBC equal to TA plus TB, which is 700 Nm. For the LBC, we obtain from the dimension of the system, which is 0.75 meter, and GBC will be equal to P over 2 C to the 4. It will give us 4.396 times 10 to minus 7 meter to the 4. After obtaining data for the first partition and the second partition, we can use the formula directly. We just need to substitute the value into the formula. After substituting them, we will obtain the VAC will be equal to 0.441 radian, or approximately equal to 25.27 degree.